2017, a Associação Portuguesa de Aeronaves Não Tripuladas, a APANT, referia um estudo feito na Europa que previa que o mercado europeu de drones crescesse e muito. 7 milhões de drones para lazer e 415 mil com utilização comercial até 2050. 7 milhões de drones! Isto vai ser um zumbido ainda maior que o das vuvuzelas no Mundial 2010. Bom, a próxima palestra pretende exatamente falar de desafios e soluções para as aeronaves não tripuladas e eu espero que digam alguma coisa vá sobre este zumbido. Passo então a palavra a Erez ElimelechHead, Head of Operation da Força Aérea Israelita. Good afternoon.
Hello. Can you hear me?
Yes.
And can you see me as well?
Yeah.
Okay.
You can start. Thank you.
Okay. So, hello, shalom, everyone. My name is Erez ElimelechHead. I'm the head of the Tactical Air Defense Marketing Manager Department in Elta IAI. And I understand that I'm the only thing that's splitting between you and lunch, so I will try to be as painful as I can. IAI is the largest defense company in Israel, and Elta is a subsidiary of IAI, and Elta is considered to be the radar house of Israel. Elta manufactured all the major sensors for the weapon systems in Israel, starting in the Arrow weapon system, the David Sling weapon system, Iron Dome, the Trophy, the active protection system for tanks, naval radars, etc., etc., etc. So, no, I'm not going to talk about ballistic threats and multi-layer defense on the defense of Israel, but I'm going to share with you the concept that the Israeli Air Force picked and decided on when it came to design the defense of Israel against ballistic threats. Actually, I was the head of the operational branch for the Israeli Air Defense Forces, so I know a thing or two regarding that concept. So when we are talking about ballistic threats, we are talking about threats that are very hard to detect. They are very evasive. They travel in high speeds. The trajectory is very complex. When the target is entering the atmosphere, it gets apart, and it's very hard job to detect what is the right target to know and to destroy. Another thing that we can say about ballistic threats is they are very accurate, most of them, not all of them. And the third thing is the threat is very cost effective. It means that instead of building an air force with a fighter jets that cost a lot of money and a lot of training of pilots, etc., the other side decided to go with something that is very cost effective, and thus we can expect a large quantities from that threat. So the Air Force decided to go with a concept that says, in order to have a defense, an umbrella of defense on Israel, I'm going to use a concept that says multi-layer, a lot of layers, each layer from a different weapon system, hopefully from a different discipline of a weapon system. And there we can see, for example, in Israel, we can see in the upper tier, in the first layer, we can see the Arrow 3, and then the Arrow 2, and then the David Sling weapon system, and the Patriot, and the Iron Dome, and some other weapon system that I cannot elaborate on. But the concept is clear. That concept gives you a higher probability of detection. It gives you an overlapping between the system, and it gives you redundancy. Redundancy between systems, if one of them is faulty, the other one is backing up. So if I'm taking the discussion now to our subject, to drones, we can see that drones have a similarity with the ballistic threats because drones are evasive too. Drones are very accurate too, and most important, drones are very cost effective. In a few $1,000s, I can create a military standard weapon that can hit a command post or airfield or a civilian airfield. As you can see here in the slide, there's a lot of examples of the trouble being made by drones in political events, in sport events, in international airports. And I don't have to mention the money spent by a penetration of small drone into international airports and grounding all the airfields because of that, power plants being hit. So we all understand that drones are bad news. So when Elta AI came to design the solution for that problem, we decided to adapt the concept from the Israeli Air Force. We went for a multi-layer, multi-sensor, multi-discipline system. And we created an anti-drone system that we call Drone Guard. Drone Guard is a well-known system around the world. Actually, we sold more than 250 systems all around the world. You can see the countries here on the slides. And the system is fielded, obviously, and it's working all around the world. When we are talking about what the system can do, we are aiming the system to UAS in Class 1 and Class 2. Class 1 and Class 2 are the classes beginning in the first and the smallest micro quadcopter, micro drone, the smallest one, like a DJI Mavic, for example, up to a small airplane, like a Cessna, that weighs approximately 600 kilograms. So this is the threats that Drone Guard is designed to deal with. The concept of Drone Guard, much as the concept I discussed with the ballistic threats, is a multi-layer. And the concept is built of three functionalities. The first one, obviously, like every air defender knows, we have to detect the target. And for doing that, we are using all the sensors that we have. We are using the radar, we are using the commit, we are using the electro-optics, the IR, and acoustic sensors. So this is the first phase. The second phase is to classify. It's not enough that we are detecting a physical target in the sky. It's a legit target. We need to know that the target is relevant to our target. For example, drones. I can detect bird. Bird is a physical target, a legit target, but it's not of my interest. I want to make sure that the target is of my interest, thus a drone. So again, I'm using all of my sensors. I'm using the radar abilities. We have what we call micro Doppler functionality in the radar. The micro Doppler can detect the rotation of the blades in the quadcopters. And we have the command system. This is another layer. The command can detect, obviously, the communication between the operator of the drone and the drone itself. The communication is being detected and sent us all the data to the brain of our system. Finally, we have the electro-optics and the IR. The electro-optics obviously can show you a picture, a video picture of the target, and there the operator can decide whether the target is legit or not, and we have an artificial intelligence layer that, again, compares the target between preloaded data or intel that we entered the system in the preliminary phases of computing it. The last phase is the interception. This is the only phase that the operator should intervene and not being done automatically. The system will advise the operator on the mitigation options, and the operator should decide whether he wants to use a soft kill or a hard kill mitigation. So the Drone Guard system is being offered in few platforms. The first platform is the portable one. Obviously, it will be a small
sensors, a small camera, etc., because you want it to be portable. The main option is the fixed one. We are using it in airfields, we are using it in civilian infrastructures, etc. And also we have an on-the-move option. The on-the-move is operational as well. We sold it to a few countries, and it's operational, and the radar can detect, all the system can detect the targets on the move. So because IAI and Elta is designing and building that system, the drone guard system, you can see that in each layer of defense, we have a large portfolio of sensors to pick up from. For example, let's go to the radar. So we can see that in the radar layer, we can choose from a small radar that is portable and rotate in X-band, or we can choose a medium-sized X-band rotating radar, or we can choose a fully AESA, non-rotating sensor for on-the-move application, etc., etc., etc. I remind you, Elta is the radar house of Israel, and we have a lot of options in that field. In the second layer, the electro-optic one, the passive layer, also IAI has a full division that deals with electro-optics. And again, the customer can decide which type of camera it wants to implement in the system. The same for passive sensors, soft kill and hard kill measures. So when we are going deeply and diving into the heart of the system, the heart and the brain of the system, this is the process that's being done inside the system. In the next slide, I will show you how it looks like from the operator side. Everything starts in the target, in the detection phase. We are using all of our methods and sensors to gather as much information as I can from the target. And we are adding a third-party integration information, and we can also add an external data, like an Intel, for example. All this data is going to the second phase. There, this is the smart phase where the system that is doing the integration, the processing, implementing a deep learning methods, and is coming to the third phase and prioritize the targets and gives the operator mitigation options, and then the operator should decide how to act and how to mitigate the target. So now I hope that you can see the video, but I will explain anyway. So this is a tactical display, the most common display for the drone guard system. On the left side, we can see the sensor control. On the right side, we can see the cameras, the day camera and the night camera. And in the middle, we can see the tactical display, the map and the functionality of the sensors. First, you can see the red line that says in the end 2.4 gigahertz. This is the comment. The comment is detecting now a target. You can see the blue insignia, the blue icon of the airplane. This is a target. It's being detected firstly by the comment. This target is emitting in 2.4 gigahertz between the operator of the target and the target itself. Second, what is going to happen now is the radar is going to join to the party and is going to detect this target as well. Next, the smart thing will be made. The combination, the correlation between the data came from the comment and the data that's coming from the radar will be integrated, and the target will be given a grade. When this grade will come to a certain level, the camera, as you can see on the right side, will slew automatically to the target, will detect it, and will display the target on the camera, as you can see on the right-hand side of the screen. If you can notice the percentage is the assumption of the system that is telling you in 80%, in 90%, I'm sure that this target is a drone
from this kind and that kind is the AI kicking in. So we have also a unified multi-system high-level C2. This is the more complex C2, the more advanced C2. We are using it not for the tactical level, for infrastructure like international airports, for example. That C2 can combine few weapon systems, few drone guard systems, like we can see in the slide that's currently being displayed. You see the three green circles. Every circle is a drone guard anti-drone system. So the command and control is integrating between all the three systems and presenting a simultaneous picture on the current time. Actually, this command and control is working now in one of the biggest international airfields in Europe. This is a ground picture taken in that international airport. So you can see the radar rotating. You can see the command, the jammer, the optics, etc. So for summarize, I can say that RI Elta does not only implement a winning air defense concept, it works too. Thank you very much.